How errors made mathematics smarter. Mistakes are supposed to be erased, corrected, hidden, but in mathematics, errors did the opposite. They became the engine of progress. Every breakthrough began with something going wrong, a result that refused to fit, a proof that collapsed, an answer that contradicted expectation. Failure was not an endpoint, it was an invitation. To understand why errors matter today, we must challenge a myth. We imagine mathematics as perfect, clean logic, flawless certainty, truth without ambiguity. But real mathematics is built on tension, on contradictions that refuse silence, on mistakes that expose hidden assumptions. Errors reveal what rules conceal. Early mathematicians trusted intuition. They assumed lines behaved predictably, numbers acted consistently, infinity stayed distant. Then errors appeared. Paradoxes surfaced unexpectedly. Division by zero exploded logic. Negative numbers felt impossible. Irrational lengths broke geometry. Each error felt threatening. At first, mistakes were rejected, dismissed as nonsense, declared invalid, but they kept returning. In different problems, different cultures, different centuries. This repetition changed perception. What if the mistake was not in the answer, but in the assumption? What if error was evidence, not failure? Once this question was asked, mathematics shifted. Rules became explicit. Definitions sharpened. Hidden assumptions surfaced. Error forced clarity. Ambiguity could no longer hide. Proofs tightened. Logic deepened. Understanding matured. The discipline did not grow by avoiding mistakes. It grew by confronting them, by asking why something failed instead of pretending it never did. This pattern repeats everywhere. When results surprise us, we learn. When systems break, they reveal structure. Mathematics became smarter not by perfection, but by resilience, by allowing errors to speak. And the most powerful discoveries often began as something that should not have happened. Something wrong, something impossible, something that refused to disappear. Once errors were taken seriously, mathematics changed posture. Instead of forcing answers to fit, thinkers examined the cracks. Contradictions became signals. If logic failed, assumptions were questioned. If proofs collapsed, definitions were refined. Error became diagnostic. This shift produced entire fields. Negative numbers explained debt and direction. Imaginary numbers solved real equations. Non-Euclidean geometry described curved space. Each began as an impossibility. What once looked wrong revealed deeper consistency. The mistake was not accepting new objects. It was clinging to old limits. Error also exposed boundaries. Some problems had no solutions. Some truths could not be proven. Some systems contradicted themselves. Mathematics learned humility. Formal proof emerged from this tension. Every step had to justify itself. Every assumption declared. Every exception addressed. Rigor was born from fear of error. Paradoxes sharpened logic. Russell's paradox restructured set theory. Gödel's work revealed incompleteness. Certainty fractured into layers. Truth became conditional. This did not weaken mathematics. It strengthened it. Understanding deepened. Scope clarified. Confidence became earned, not assumed. Errors also improved tools. Numerical methods embraced approximation. Error margins became explicit. Accuracy replaced perfection. Reality entered calculation. Science adopted this mindset. Models acknowledged limits. Predictions included uncertainty. Error bars became honest. Progress accelerated. The emotional shift mattered too. Mistakes stopped being shameful. They became informative. Exploration replaced avoidance. Curiosity replaced fear. Mathematics learned to listen when answers felt wrong, because wrongness often pointed toward unseen structure. The discipline matured when it stopped pretending to be infallible, and that maturity prepared for an even deeper confrontation. Because some errors could not be fixed, they could only be accepted. This is where the conflict reaches its deepest point. Some errors refused correction. No refinement made them disappear. They were not mistakes in calculation. They were limits of the system itself. Gödel proved this unsettling truth. In any system powerful enough to describe arithmetic, there exist true statements that cannot be proven within the system. Error was no longer accidental. It was structural. This revelation shattered old confidence. Mathematics could not be both complete and consistent. Certainty demanded sacrifice. Either some truths will remain unreachable or contradictions would appear. The idea was emotionally destabilizing. For centuries, mathematics promised certainty. Now it admitted blindness, not from ignorance, but from design. Other limits emerged. The halting problem showed some computations could never finish. Chaos theory revealed tiny errors could explode unpredictably. Precision met instability. These were not flaws to repair. They were boundaries to respect. Error became permanent, unavoidable, meaningful. This forced a philosophical shift. Knowledge stopped being absolute. It became contextual. Models replaced truth. Understanding replaced certainty. Mathematics did not collapse. It adapted. It learned where it could speak and where silence was honest. Error defined the edges of meaning. This humility proved powerful. Systems became safer. Assumptions clearer. Overconfidence declined. Design improved. The conflict between perfection and reality resolved quietly, not by eliminating error, but by integrating it. Mathematics grew wiser. It stopped promising certainty. It promised insight instead. And insight survives limitation. Error was no longer the enemy. It became the map, showing where structure ended and mystery began. And at that boundary, mathematics found its most human quality, not infallibility, but understanding. The climax of error is not correction. It is integration. Once mathematics accepted error as permanent, it stopped chasing impossible perfection. It focused on usefulness, clarity, boundaries. Proofs became conditional. Models became provisional. Confidence became measured. Error was no longer hidden. It was documented, bounded, respected. This changed how knowledge advanced. Progress stopped meaning certainty. It meant deeper questions, better approximations, clearer limits. Modern mathematics thrives on this realism. Algorithms tolerate noise. Systems expect failure. Design anticipates breakdown. Resilience replaces fragility. The same lesson spread beyond numbers. Engineering plans for error. Science reports uncertainty. Medicine weighs risk. Society learned that ignoring limits is more dangerous than admitting them. The original mistake was believing error meant failure. Mathematics corrected that illusion. It showed that error is information, a signal, a guide. When we listen to what goes wrong, understanding grows. When we deny it, systems break silently. Error demands humility. It rewards attention. This is why mathematics became smarter, not because it eliminated mistakes, but because it learned from them. It allowed contradiction to speak. It let limits define wisdom. In a world obsessed with certainty, this lesson matters deeply. Progress does not come from perfection. It comes from adaptation. Error does not end knowledge. It shapes it. And in that shaping, mathematics discovered its greatest strength. Sometimes the smallest shift in perspective becomes the beginning of a new future. How